In our previous videos, given the continuous time signal x of t, we have seen how to find Fourier transform and how to get x of j omega. Now, under this section, we will be studying given x of j omega, how to find x of t back, that is inverse CTFT. Now, the first problem is x of j omega is equal to 2j omega plus 1 divided by 2 plus j omega whole square. Now, if I do the individual division, I will be getting 2j omega divided by 2 plus j omega whole square plus 1 by 2 plus j omega whole square. That means I have divided the numerator individually by the denominator value. Now, if x of t forms Fourier transform pair with x of j omega, we know that e power minus at u of t forms Fourier transform pair with 1 by a plus j omega, and t into e power minus at u of t forms Fourier transform pair with 1 by a plus j omega whole square. This problem we have already solved in finding the CTFT of a function. So if you want, you can refer to my previous lectures on CTFT, how to find CTFT when x of t is given. Now, what I have here is, in place of a, I have 2. So it will be t into e power minus 2t u of t forms Fourier transform pair with 1 by 2 plus j omega whole square. So the inverse Fourier transform of this function is known. Now I need to find this inverse Fourier transform of this function. Now we know the property. See, we need to get j omega in the numerator. So we have already solved a property called differentiation property in time domain, wherein d by dt of x of t forms Fourier transform pair with j omega into x of j omega. Now if I take my x of t as this, it is d by dt of t into e power minus 2t into u of t forms Fourier transform pair with j omega into, what is x of j omega? X of j omega is Fourier transform of x of t, and my x of t is t into e power minus 2t u of t. What is its Fourier transform? J omega divided by 2 plus j omega whole square. Now if you see closely here, you have a factor 2, right? So if you want to get a 2 here, 2 in the numerator, I need to multiply that 2 here as well, right? So I'll be getting 2, if I cross multiply, 2 into d by dt of t into e power minus 2t u of t as the Fourier transform pair with 2j omega divided by 2 plus j omega whole square. So this is the Fourier transform, inverse Fourier transform of 2j omega divided by 2 plus j omega whole square. So if I take inverse Fourier transform, inverse ft for both terms, I'll be getting this one as 2 into d by dt of t into e power minus 2t plus, what is the inverse Fourier transform of 1 by 2 plus j omega whole square? It is t into e power minus 2t into u of t. So what is the differential of t into e power minus 2t? It is UV rule, the product rule. T into differentiation of e power minus 2t, e power minus 2t into minus 2 plus e power minus 2t into differentiation of the first term, that is t. So it is 1. Differentiation of t with respect to t is 1. Differentiation of e power minus 2t with respect to t is e power minus 2t into minus 2. So this is the one term in plus t into e power minus 2t into u of t. So what I will be getting is 2 into minus 2t e power minus 2t plus e power minus 2t into u of t, because there was this factor of u of t here as well as here, plus t into e power minus 2t u of t. So this will be minus 4t e power minus 2t u of t plus 2 into e power minus 2t u of t plus t into e power minus 2t u of t. Minus 4t plus t, it will be minus 3t. So what I will be getting is 2 into e power minus 2t u of t minus 3t into e power minus 2t u of t. This is the inverse Fourier transform. Since I have already taken inverse Fourier transform here, I will be getting x of t back. So this is how I got the inverse Fourier transform of x of j omega, which is 2 j omega plus 1 divided by 2 plus j omega whole square. That means I just converted the time domain, frequency domain signal back to time domain signal, whereas in the previous cases I was finding frequency domain signal from given the time domain signal. Now the second problem is x of j omega is equal to e power minus mod omega. Now we have already seen how mod function works. So this can be written as x of j omega is equal to e power minus omega for omega greater than 0, and it is e power omega for omega less than 0, because for negative values it will be minus omega, so you will be getting e power positive omega. Now what is inverse CTFT equation? That will fetch you x of t. This is from the basics, 1 by 2 pi integral minus infinity to infinity x of j omega e power j omega t d omega. Now x of j omega is not continuous throughout the values of omega, because it is having different values for different values of omega. So it is 1 by 2 pi. I can split this integral for negative values of omega, that is omega less than 0. So minus infinity to 0. In that range x of j omega is e power omega into e power j omega t d omega, plus for positive values of omega, that is 0 to infinity, for positive values of omega x of j omega is e power minus omega e power j omega t d omega. So if you integrate this, it will be like minus infinity to 0 e power, if I take omega out, I will be getting 1 plus jt into omega into d omega, plus 0 to infinity, if I take minus omega out, minus, I will be getting 1 minus jt into omega. The reason I took plus omega out here and minus omega out here is, if I substitute the limit minus infinity to omega, because integration is with respect to omega, if I substitute this limit to omega as minus infinity, e power minus infinity will be 0. Whereas if I take omega out and substitute infinity, it will be infinity, e power infinity will be infinity. That is why if I take minus out, so e power minus infinity will be 0. So 1 by 2 pi into integration of e power x e power omega, it is e power 1 plus jt into omega divided by 1 plus jt, because this is a constant term, and remember we are integrating with respect to omega, that is omega is equal to minus infinity to 0 plus e power minus 1 minus jt into omega divided by minus 1 minus jt from 0 to infinity. Now if I substitute the limit, this is a constant which is independent of omega, so I can take it out, 1 by 1 plus jt into, if I substitute the upper limit to omega, e power 0 is 1 minus e power minus infinity, because I am substituting the values for omega. So it is e power minus infinity is 0 minus 1 by 1 minus jt. This minus sign comes here. So if I substitute the upper limit, e power minus infinity is 0, lower limit it is 1. So this is what I get. So I'll be getting 1 by 2 pi into, this is 1 by 1 plus jt here, and minus, and you have a minus sign inside, so it will be plus 1 by 1 minus jt. So if I take the common denominator, it is 1 by 2 pi into, it is 1 plus jt into 1 minus jt, it is a plus b into a minus b, a square minus b square, it is 1 minus j square t square. In the numerator you have 1 minus jt, because this term will come first, plus 1 plus jt. So these two gets cancelled, you get 2, and that 2 gets cancelled by the 2 in the denominator. So I will be getting 1 by pi into 1 divided by 1 minus j square is what? Minus 1. So I will be getting 1 plus t square. So this is x of t, that is inverse Fourier transform of x of j omega. As you can see, it is only having the function of, it is the function of t, it is not having any omega terms. So this is the inverse Fourier transform of e power minus mod omega. So in this problem, you're asked to evaluate the integral of 4 by omega square plus 1 whole square d omega. Now this is a tricky problem wherein you need to use a Parseval's theorem, because you have x of j omega whole square kind of a thing here. So what is Parseval's theorem? It says that integral minus infinity to infinity modulus of x of t whole square dt is equal to 1 by 2 pi integral minus infinity to infinity x of j omega whole square d omega. Now this is of the form integral x of j omega whole square d omega, where what is x of j omega? If it has to be a whole square, x of j omega has to be 2 by 1 plus omega square. You have a whole square of it. So this is of this form. So what from this, what do I get? Minus infinity to infinity x of j omega whole square d omega as 2 pi into integral minus infinity to infinity modulus of x of t whole square dt. This is what I get. So if I cross multiply by 2 pi, where x of j omega is 2 by 1 plus omega square. Now what I need here is, what is x of t? X of t means what? X of j omega's inverse Fourier transform, x of t. And the left hand side is the same, because x of j omega is 2 by 1 plus omega square. So left hand side would be integral x of j omega whole square, it is 4 by 1 plus omega whole square. Now what is x of t whose Fourier transform is 2 by 1 plus j omega whole square, or 1 plus omega square. Now we already know that e power minus a mod t forms Fourier transform pair with 2a divided by 1 plus omega square. Okay. Sorry, it is 1a square plus omega square. E power minus a mod t forms Fourier transform with 2a divided by a square plus omega square. So this Fourier transform problem we have already solved in the previous problems. So if you want to check whether the Fourier transform of e power minus a mod t is equal to 2a divided by a square plus omega square, then go back to my previous videos and have a look at it. So e power minus a mod t is 2a by a square plus omega square. Now in place of a, if I put a as 1, so I will be getting e power minus mod t forms Fourier transform pair with 2 divided by a is 1 plus omega square. So this is the x of j omega, this is x of j omega. What is this? This is x of t. So my x of j omega what I have got here is equal to the x of j omega what we have in our problem. So from this we are sure that the inverse Fourier transform of x of j omega, that is 2 by 1 plus omega square, is e power mod t. Now that I need to integrate here in order to get the integral minus infinity to infinity 4 by omega square plus 1 whole square. I think I've made it pretty much clear. So if I start from here, so it is minus infinity to infinity. What is my x of j omega? It is 2 by 1 plus omega square whole square is equal to, and d omega is equal to 2 pi into integral minus infinity to infinity. X of t is e power minus mod t, e power minus mod t whole square into dt. This is what I get. So in the left hand side, minus infinity to infinity, 2 square is 4 divided by 1 plus omega square whole square d omega. This is what I get, and this is what I want. So that integral is equal to 2 pi into, now we have e power mod minus mod t. It is, we know the behavior of mod function, it is e power t for t less than 0 and e power minus t for t greater than 0, greater than or equal to 0. So I can split this integral as minus infinity to infinity for negative minus infinity to 0 for negative values of t. What is its value? E power t whole square dt plus 0 to infinity. What is its value? E power minus t and whole square dt. Why do I get a whole square? Because it is x of t whole square. So the value, you have 2 pi. It is e power 2t. E power 2t integral is e power 2t by 2 from minus infinity to 0 plus e power minus t, e power minus 2t. E power minus 2t integral is e power minus 2t by minus 2 from 0 to infinity. So that will be equal to 2 pi into, if I substitute the upper limit as 0, it is half is a constant, 1 by 2 is a constant, 0 means 1 minus e power minus infinity 0. Again you have upper limit to be infinity, e power minus infinity is 0 minus e power 0 is 1, so I'll be getting this. So it will be 2 pi into half minus half into minus 1, so plus half. Half plus half is 1, so finally the integral minus infinity to infinity 4 by 1 plus omega square whole square d omega is 2 pi into 1, so the answer is 2 pi. Now in this problem you have been given with a rectangular pulse and you are asked to find the inverse Fourier transform of it. So if you remember, we have solved a similar problem of rectangular pulse varying from minus t to plus t with an amplitude of 1 where x of t was given. Then we had found the Fourier transform of it, and it was equal to 2t into sinc omega t by pi. That means we will be getting a sinc pulse if the time domain signal was existing between minus t to plus t. That means the Fourier transform of a rectangular pulse is a sinc pulse. So if you want to have a look into it, that means the rectangular pulse with width 2t formed Fourier transform pair with a sinc pulse, right? So these two form the Fourier transform pair. So if you want to have a look into it, this problem, please look into the video where I have solved finding Fourier transform from time domain signal. Now here you are given with the frequency domain signal that is existing between minus w to plus w. See, make out the difference. This is w and this is omega. Now you need to find the inverse Fourier transform of it. So what is inverse Fourier transform equation? X of t is equal to 1 by 2 pi integral minus infinity to infinity x of j omega e power j omega t t omega. This is from the fundamentals. But my x of j omega is existing between minus w to plus w, as in the case of time domain signal which existed between minus t to plus t. So this minus infinity to plus infinity will become minus w to w x of j omega. What is its value in that range? It's 1 into e power j omega t d omega. Remember, this is omega and this is w. So if I integrate this, it will be e power j omega t divided by, I'm integrating this with respect to omega, so jt is a constant from w to minus w. So I'll be getting 1 by 2 pi j t into, if I substitute the upper limit e power j, I need to substitute it for omega because the integration was with respect to omega, e power j w t minus e power minus j w t I get, because upper limit is omega, e power j w t minus e power minus j w t, and this is 1 by 2 pi j t. So if I rearrange, I'd be getting e power j w t minus e power minus j w t divided by, out of these factors, if I take 2j common here, I mean 2j for this, and I'll be left out with pi into t. So 1 by pi t, I'll be getting 1 by pi t into, what is this? E power j theta minus e power minus j theta divided by 2j is sin theta. So what do I get here is, I'll be getting sin wt. This entire function is sin wt. Now if I want to convert this function into sinc function, now sinc function is sin pi theta divided by pi theta. This is my sinc function, which is sinc of theta. Sinc of theta is equal to sin pi theta divided by pi theta. Now I need to convert this in the same form, so pi t sine of, I need to have pi into theta. What is theta here? W into t. So I should have pi into w into t. So in order to get rid of this pi, I need to divide by pi. So what is my new theta? It is w t by pi. So this is of the form sin pi into theta, where theta is wt by pi, but in the denominator also I should have pi into theta. So I have already pi here, so I'll take that pi here. Pi into theta is what? W. T already I have it here, t divided by, I need to have pi. So in order to get rid of this pi, newly formed pi, I need to multiply here by pi. In order to get rid of w, I need to multiply the numerator by w. So I will be getting w by pi into sin pi wt by pi into pi wt by pi. This is of the form sin pi theta divided by pi into theta. So this is the multiplying factor that which I have it here, because you already had pi, you already had t. So pi I have taken here, t I have taken. I need to multiply by w in the denominator. So in order to nullify it, I will multiply the numerator by w. So I have divided the wt by pi. So in order to nullify it, I need to multiply here as well by pi. So I will be getting w by pi into sinc of wt by pi. So this is the inverse Fourier transform of the given function. Now, as you can see, when the time domain signal was x of t was a rectangular pulse, the frequency domain signal was sinc pulse. Now, when the frequency domain signal was a rectangular pulse, the time domain signal is again a sinc pulse. So I think you are well aware of drawing a sinc pulse, that is with respect to t, you will be getting a sinc pulse which is looking like this, and with an amplitude. What is amplitude here? It is w by pi. How do I get that? If I put t is equal to 0, I will be getting sine 0 by 0. So it is, so sine 0 by 0, it is undefined. So use the L'Hospital's rule. So differentiate here with respect to t, you get w into cos wt and you get pi. So w by pi is the amplitude at t is equal to 0. I think similar kind of problem I have solved for rectangular pulse in time domain. So what is this? This point is, I need to look at t. So if t is pi by w, sine pi will be 0. So this is minus pi by w, not omega, this is w. So the point at which my x of t goes to 0 is pi by w and minus pi by w, and it continues for 2 pi by w, 3 pi by w and so on, because sine function is 0 for pi, 2 pi, 3 pi and so on. So the first value of pi, first value of t for which my sinc pulse goes to 0 is pi by omega, and to the left side it is minus pi by omega, and the amplitude here is w by pi. So this is the inverse Fourier transform of a rectangular pulse given in frequency domain. Now in this problem you have been given to find integral of sine square pi t divided by pi t into dt. So we know that the inverse Fourier transform, which I have solved previously, the inverse Fourier transform of a rectangular pulse, if x of j omega is given to be this, from minus w to plus w, its inverse Fourier transform is a sinc pulse, right? And the sinc pulse, what I'll be getting is 1 by pi t into sine w into t, right? It is also a sinc pulse. So here w and you have omega. So if my frequency domain signal is extending from minus w to plus w, this is my inverse Fourier transform. Now if I put the value of w, if w is equal to pi, that means my x of j omega is extending between minus pi to plus pi with an amplitude of 1, then the inverse Fourier transform is 1 by pi t into, instead of w I need to substitute pi, so it is sine pi t. So this is what I have got here. It is sine pi t divided by pi t whole square. Again, if you have a squared term and if you have an integration, the best option to find this integral is Parseval's theorem. It is minus infinity to infinity x of t whole square dt is equal to 1 by 2 pi into integration minus infinity to infinity x of j omega whole square dt. Now what is my x of t here? It is sine pi t by pi t. So if I write this here, minus infinity to infinity sine pi t by pi t whole square dt, it is x of t, is equal to 1 by 2 pi integration minus infinity to infinity. What is x of j omega? It is this function. So how do I model it mathematically? X of j omega is 1 when omega is between minus pi to plus pi, because when omega is minus pi to plus pi, x of j omega amplitude is 1, 0 otherwise. So minus infinity to infinity, I will write it as it is for now, then I will substitute the limit x of j omega whole square d omega, not dt, d omega. So my x of j omega is existing between minus pi to pi, because its inverse Fourier transform is sin pi t by pi t. That is what we have. So left hand side, it is sin square pi t divided by pi t whole square dt is equal to 1 by 2 pi. What is the integration limit? Minus pi to plus pi, because my x of j omega is existing between minus pi to pi. And what is its value, amplitude? It is 1 into d omega. So it is 1 by 2 pi into integration of 1 with respect to omega is omega from pi to minus pi. So I will be getting 1 by 2 pi into pi minus pi. So it is 2 pi, 1 by 2 pi into pi plus pi, it is 2 pi. So the answer is 1. So the integral minus infinity to infinity sin square pi t divided by pi t whole square dt, the integral is equal to 1. So in this problem you are given with x of j omega is equal to 5j omega divided by j omega whole square plus 3j omega plus 2. Now the best method to solve this is by partial fraction, by factorizing the denominator. Now for simplicity purpose I will substitute j omega as t. So I will be getting 5t divided by t square plus 3t plus 2. Now if I factorize this, it will be 5t divided by t plus 2 into t plus 1. t plus 2 into t plus 1 is t square plus 3t plus 2. So by partial fraction, this can be reduced as a by t plus 2 plus b by t plus 1. Now the partial fraction equation, what I get is a into t plus 1 plus b into t plus 2 is equal to 5t. Now how do I get the values of a and b? It is put t is equal to minus 1. So a will be 0 here, minus 1 into minus 1 plus 1 0. Minus 1, I will be getting b is equal to minus 5. Now how do you get the value of a? Put t is equal to minus 2. The simplest of the things to solve this equation is make this function to be 0, that is possible when t is equal to minus 1, and make this function to be is equal to 0, that is when t is equal to minus 2, you get b is equal to 0. So if it is minus 2, I will be getting minus a is equal to minus 10 and a is equal to 10. A is equal to 10. So this partial fraction expansion is 10 divided by t plus 2 plus, the second b term is minus, so minus 5 divided by t plus 1. Now if I replace it back, 10 divided by 2 plus j omega, it is in place of t I will substitute it as j omega, minus 5 divided by 1 plus j omega. This is my x of j omega. So I was able to convert rational value into sum of two functions whose inverse Fourier transform we already know. So taking inverse Fourier transform, see we know that e power minus at forms e power minus at u of t forms Fourier transform with 1 by a plus j omega. So in place of a I have 2. So what is the inverse Fourier transform? 10 into e power minus 2t u of t minus 5 into, in place of a I have 1, so it is e power minus t u of t. So it will be 5 into 2 e power minus 2t minus e power minus t into u of t. This is my x of t. So this is the inverse Fourier transform of the function, which is x of j omega is equal to 5j omega divided by j omega whole square plus 3j omega plus 2. Now, so I have solved many problems under inverse Fourier transform, basically inverse CTFT, which have appeared in the previous year's question paper, as well as which I have found it very important. Thank you for watching.